Hi, I'm Dominic. I finished my thesis on improvements in probe placement in dynamic diffuse global illumination. We have implemented the original work by Meyerchik and evaluated its usage in architectural visualization. We have explored its pros and cons and presented improvements to avoid its artifacts. If you want more know about our improvements and how we dealt with those artifacts, come to my talk or see my paper.
I'm Michal Hviezda from Czech Technical University in Prague. In my paper, I evaluated a real-time global illumination algorithm called dynamic diffuse global illumination in terms of performance and quality of the final image. I detail my implementation of the algorithm and how it leverages modern ray-traced GPU hardware to compute diffuse light transfer for a given scene. If you would like to know more on how to implement such algorithm and see results of my evaluation, come to my talk. I'm looking forward to seeing you there.
Hello, I'm Vojta from the Czech Technical University in Prague. My goal was to create a web environment for city planners where they could explore large static and dynamic datasets. The system utilizes a versatile data model, several spatial and temporal data structures, and the custom styling language. I also thought about the interface and ended up using Lego models as a presentation medium. If you are interested, feel free to check out my presentation.
Hi, I'm Martin Piliar from Pan-European University. In my work, I developed a real-time interconnection platform used to connect virtual and augmented reality devices called PhysioGo. The platform is implemented by utilizing commercially available software solutions such as Vuforia or photon networking. If you are interested in virtual or augmented reality devices, please feel free to check out my presentation.
Hello, I'm Sanga from the University of Sarajevo. In our paper, we evaluated how users perceive camera movement, one of the techniques of classical filmmaking, and 360 video. We recorded 3 sets of 360 videos with different amounts of movement and developed a VR application to present them to users. In order to test our hypotheses, we conducted a UX evaluation study in order to analyze whether this movement adds to immersion in VR or causes unbearable motion sickness. If you are interested in 360 video and VR, please come to our presentation and read our paper.
Hi, my name is Michaela and I wrote a state-of-the-art report about processing speed and comprehensibility of visualizations and texts. In my presentation, we will try to find answers for the questions if visualizations or texts are processed faster by humans and which one is better comprehensible.
Hello, my name is Michaela. I am from the Slovak University of Technology, and together with my colleague Jakub, we studied the impact of education on human visual attention. We conducted an eye-tracking study consisting of 3 modules on 2 groups of university students. We analyzed the differences in visual attention while freely viewing visual stimuli and completing visual search tasks. The participants of our study were students with different backgrounds in education, that is, technical and non-technical students. If you'd like to know the results of our study, we invite you to come and see our poster.
Hello, I'm Maroš from Slovak University of Technology, and the topic of my work is multi-class texture synthesis using generative adversarial networks, where I focus on controllable synthesis of multiple non-stationary textures from real environments. My solution provides both the controllability of texture class and also intra-class variation. If you're interested to hear more about this topic, I would like to invite you to my presentation.
Hello, my name is Balázs Szőke. I'm from Budapest University of Technology and Economics, and I will talk about analyzing architectural floor plans using neural networks. I will present a system that is capable of obtaining a parametric representation of a floor plan and building a 3D model from this representation. If you're interested in this topic and want to know how to achieve this only from a 2D image, then come see my presentation on Friday. Thank you.
Hello, I'm Paul from Graz University of Technology. My paper is about training algorithms for sparse neural networks. I created two new algorithms for weight relocation using an approximation of the second-order derivative. Then I compared them to existing methods in terms of network accuracy and the computational cost of training. If you're interested in new ways to create more accurate and efficient neural networks, check out my presentation.
Hi, I'm Gaia and I'm an Erasmus student at the Charles University in Prague. For my master thesis, I'm working with 3D printers and renderers. Our goal is to create a shader that will match the appearance of FDM printouts without explicitly modeling the geometry and reflectance characteristics. If you're interested in learning more, please come to my talk.
Hello, my name is Dennis Stebner. I'm a student at Vienna's University of Technology. In my work, we present a method for improving depth image integration in the Kinect Fusion algorithm for 3D surface reconstruction. To do that, point cloud information of previous depth images is aggregated as median vectors and used for 3D surface calculations. If you're interested in learning more, I invite you to my talk and see you there.
Diffusion-based methods, often inspired by nature, can be used as a tool for filling holes and even remeshing polygonal surfaces. We implemented a shrink wrapper tool for a variety of triangle meshes and tested the stability of our model. Curious about how we've done it? Feel free to come to my presentation on Friday.